All right, so let's take a peek at numbers 13 through 15. Here's a quick little video on these little guys here. And these are a couple properties I should have put in your notes. They're actually really easy. When you look at, if you have a log and you have a base, doesn't matter what the base is. So one of the properties says if I have log base b of basically b to a power, then what happens is the log base b and the b cancel, and I'm just left with the exponent. So if I have, for example, log base 4 of 4 to the third power, then technically those two things cancel, and I'm just left with 3. Another way you can think about it is if we said, okay, if I have log base 4 of 4 cubed and I set that equal to x, well, then I can say, rewrite it with exponential 4 to the x power equals 4 to the third power. Well, then x has to equal 3. And that's more or less what you're doing. We're just not putting an extra variable in the problem. So if I have problems that look like this, log base 3 of 9, well, I want to rewrite this as the log base 3 of 3 squared, and then technically that log base 3 and the 3 cancel, and my answer is 2. And again, we saw that when we rewrote it in exponent form. We would say, well, if this is log base 3 of 9 equals x, well, 3 to the x equals 9. Well, 9 is 3 squared, so x has to be equal to 2. So the goal is to rewrite some of those as the base to a power. And then you can cancel out the base and the base on the log, and then you're just left with the exponent as your answer. Now, with natural log, and you can also do the same thing, is if I have b raised to the log base b of something, so I'm just going to put the number 2 there, technically they cancel in this aspect as well, and my answer is just 2. So if you have a number being raised to a logarithmic power and the base on that logarithm matches the base down below, then those two things cancel and you're just left with what's after it. So if you have like 5 raised to the log base 5 of 40, well, then the answer technically is just 40. Those two things just cancel. And again, there's a longer process you can go through by setting it equal to x and then rewriting it and doing some stuff, but more or less the property lets us cancel those things out. Same thing works out with e. If I have e raised to the ln power, and it's, let's say e to the ln of 3, well, the answer is technically just 3, because e and ln are inverses of each other. And remember, as I showed in class today, we could rewrite ln as log base e. And so now that would cancel like I did up above with the 5s. And my answer is 3. We also want to think about if I have the ln of e to the 4th power. In this case, the ln and the e cancel, and I just get 4. Again, the reason behind that is if I have the ln of e to the 4th, that's the log base e of e to the 4th. We just learned in this previous thing that those two things cancel and I get 4. Or I could do the whole rewriting thing and say that that's equal to x, so e to the x equals e to the 4, so x has to equal 4.